All right, in this lesson, we're going to look at solving compound inequalities. Now, before we look at what we mean by solving a compound inequalities, let's review. So this is a review of solving a simple inequality. Solving a simple inequality. All right, so for example, here's an example of a simple inequality. We have 2x plus 1 is less than, let's say, 5. All right, so 2x plus 1 is less than 5. Notice we consider this a simple inequality, and we consider that a simple inequality for the fact that there's only one inequality symbol. See, there's all you see is just one inequality symbol. In this case, it's less than. And so to solve this simple inequality, remember now this is a linear inequality, so that's easy to deal with. We're going to isolate the variable x by itself. So I'm going to subtract 1 from both sides. And so I get 2x, 1 and negative 1 is 0. When I combine like terms, 5 minus 1 is 4. And then to get x by itself, you're going to divide both sides by 2. And so when you reduce, 2 divided by 2 is 1. 1 times x is x. And so x is less than. And then 4 divided by 2 is 2. So what you found with this, what you found is that the solutions to this inequality here, the numbers, the values of x, the real numbers that will make this left side less than 5 will be any number less than 2. Okay, so for example, 0. 0 is less than 2. What's 2 times 0? 0. 0 plus 1 is 1, and 1 is less than 5. Negative 3 is less than 2. 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. Negative 5 is less than 5. So there are an infinite number of solutions. So what you did, remember to graph this, was let's say this is 0, you put 2 on the number line. There's no equal sign, right? So remember, when there's no equal sign, that's a strict inequality. I'm using the word strict inequality. And so we have, we're going to use an open circle. If there's an equal sign, you use a closed circle, and the solutions would be any real number, whether it's rational or irrational, that's less than 2. And so there's the graph. You make sure you draw the arrow. So you're shading like this, and so there's the graph of this. Now, in an interval notation, remember, you always really graph from left to right when putting in an interval notation. So you're going from negative infinity to 2 with parentheses. Negative infinity, comma, 2 with parentheses. And so that's how you solve the simple inequality. Now what we want to do, though, is solve a compound inequality. So here's the example. So let's look at solving a compound inequality. So solve each compound inequality. All right, so what makes something a compound inequality versus a simple inequality? Well, here's an example. So let's try this number 1. So number 1, we have negative 64 is less than 6x minus 4 is less than a negative 22. All right, so that is a compound inequality. What makes it a compound inequality is the fact you have 2 inequality symbols. There are 2 of them. Notice, though, another important aspect of this is that those inequality symbols are pointing in the same direction. Less than, less than. If this was less than equal to, you see less than equal to, and then possibly less than as well, or it could be less than equal to. But regardless of whether there's an equal sign or not, if this says less than, this is less than. If this says greater than, this is greater than. Okay? The inequality symbols point in the same direction. Okay, so then the question becomes, well, how do I solve this compound inequality? I know how to solve something that looks like this. That's very simple to solve. But then how would I solve this? Well, there are 2 approaches we're going to take. Now, here's the first approach. The first approach is to rewrite this so that it looks like one inequality symbol. All right, now here's how we're going to do this. Okay, now when I'm going to read this, I'm going to read this again. So this how you'd read this. You would say negative 64 is less than 6x minus 4, and 6x minus 4 is less than negative 22. So let me rephrase that. This part that's in the middle, notice there are 3 parts here. You have the part that's in the middle, you have a right-hand side and a left-hand side, right? Okay? Middle part, right-hand side, left-hand side. This middle part, when you look at this middle part says this. 6x minus 4 must be less than negative 22. I'm going to split it up like this. 6x minus 4 must be less than negative 22. That is what this part says. So notice I'm covering up this part here. So 6x minus 4 is less than negative 22. So notice that when I cover that part up, it kind of looks like a very simple inequality, doesn't it? So that's one approach. One approach is to rewrite this as a simple inequality that you can easily deal with. Okay? Now, but be careful, there are two inequality symbols. So you also have to kind of look at it this way as well. Well, 6x minus 4 is less than negative 22. And, notice I'm using the word and, that's important. And at the same time, negative 64 must be less than 6x minus 4. Negative 64 must be less than 6x minus 4. Okay? All right, so again, 6x minus 4 must be less than negative 22, and at the same time, negative 64 must be less than 6x minus 4. Okay, and it doesn't matter whether you put this here or this here, it does not matter. Okay, but what's important is notice that this approach that we're using right now takes this compound inequality and writes it as two simple inequalities. One inequality symbol, one inequality symbol. Make sure you see that the important word here also is and. All right, so when you're solving this compound inequality, you're looking for all real numbers of x that will make this middle part less than negative 22 and at the same time greater than negative 64. You may say, well, you use the word greater than, this is less than. All right, so I want you to think about something, because we're going to need this in a little while. If I tell you that 2 is less than 5, that's a true statement, right? 2 is less than 5. Is it correct to also say that 5 must be greater than 2? So if 2 is less than 5, then 5 must be what? Greater than 2, right? If I say negative 3 is less than 6, then you can also say 6 is what? Greater than negative 3. If I tell you 4 is greater than or equal to 0, then what else can you say? You can also say 0 is what? So if I tell you 4 is greater than or equal to 0, you can also say 0 is less than or equal to 4, right? Okay? So if I tell you that 3 is less than x plus 5, then what else can you say? You can say what? X plus 5 is what? Less than 3. I'm sorry, greater than 3, right? So if 3 is less than x plus 5, then x plus 5 must be greater than 3. So notice these symbols just reversed. So whenever you write it backwards, so if 2 is less than 5, and you write it backwards, you're going to say 5 is greater than 2. If negative 3 is less than 6, and you write it backwards, you're going to say 6 is greater than negative 3. If 4 is greater than or equal to 0, and you write it backwards, and you write it the other way, reverse order, you're going to say 0 is less than equal to 4. If 3 is less than x plus 5, you're going to say x plus 5 is greater than 3. Okay? That's going to be important in a little while. All right, now, so let's go back to this problem. So I have this compound inequality. I'm going to split it apart into two simple inequalities. And now we're going to solve each of those inequalities, each of those simple inequalities, just like we did this previous one. Okay, so let's do that. So to solve this simple inequality, I'm going to add 4 to both sides. And so I get 6x is less than negative 18, right? Divide both sides by 6. 6 divided by 6 is 1. 1 times x is x. I get x is less than negative 3. So negative 18 divided by 6 is negative 3. You have to reduce it. Now what I found, I'll be careful, what I found is that any number less than negative 3, any real number less than negative 3 is a solution to this only. Okay? Because remember, we are solving this, so this is so any number less than -3 is a solution to this only, so be careful. Don't say it's a solution to the original. This is only a solution to this. So that's important. Now we're going to solve this inequality. So I'm going to add 4 to both sides. -64 plus 4 is a -60 is less than 6x. -4 and 4 is 0. Divide both sides by 6. -60 divided by 6 is a -10. It's less than, and then that's just x. All right, now, most students prefer, see how x is on the left-hand side? Most students prefer to have x on the left-hand side as well. It does not matter. You can leave it like this, but remember what this says. The solutions to this right here are any number. So basically, this is saying that -10 is the smallest of all the real numbers that will be a solution to this. Or if you want to rewrite it, you can say x. So if -10 is less than x, then x must be what? Greater than -10. Okay? So this right here means -10 is less than x, means x is greater than -10. So keep that in mind. Now what you're going to do is you're going to put, now remember, this is a solution to this only. This is the solution to this only. Now we've got to figure out what is the solution to the original. And that's where the word and is going to be important. So here's what you have to do now. So on the number line, we're going to put -3 and -10 in correct order. So -10 is less than -3. So make sure you put that correctly. And we're going to graph each of these individually. So x is less than -3. Open circle because there's no equal sign. And go shade to the left because it says I want all the real numbers less than -3. This right here, I'm going to use this one. This right here says that all my solutions to this inequality will be any real number greater than -10. All right. Now, I want to find the solution to the original. So the solution to the original says this. All of my solutions to this will be any real number less than -3 and at the same time must be greater than -10. And so when you see that word and, you're going to think of the intersection of those two graphs right here. And so the solution to the original would be, if you look at it in terms of a graph now, the solution to the original would be any number between -10, open circle, because there's no equal sign, any number between -10 and -3, not including -10 and 3, just any real number between those. Okay? So that's the solution, graph of the solution to the original. So you would put that as your graph, not this. And then the interval notation of the solution, that's easy. You just read it from the graph and you always go from left to right. So parentheses, open circle, parentheses, -10, comma, -3, parentheses. All right? And so notice, I want you to realize there's an infinite number of solutions here because you have all these rational, irrational numbers that's between -10 and -3. All these decimals that don't terminate. So you have an infinite number of solutions here. So that's why we graph it. You can't finitely list all those solutions. So, for example, what we found is the solution to the original, right? Okay. So look, -5 is in here, right? So let's see why -5 is a solution. What is 6 times -5? -30. What's a -30 and a -4? A -34. Is a -34 less than -22? Yes. Is a -64 less than a -34? Yes. So that's why -5 works. 0 is not in here, right? So 0 is outside. So 0 is on this side. It's not shaded. So 0 is not a solution to the original. Let's see why not. What is 6 times 0? 0. What's 0 minus 4? -4. Is a -4 less than -22? No. -4 is greater than, right? So that's why 0 is not a solution. All right, so all we found are solutions, and that's it. So let's kind of review this. When solving a compound inequality, we're going to, one approach is to split it up into two simple inequalities. You're going to solve each simple inequality. Now remember, when you solve each one, you're finding solutions to this one, to the first simple inequality, and you're finding solutions to the second simple inequality. Remember though, you're trying to solve the original. The original was a compound inequality. So to find the solution to the original, you're going to first of all think about each one individually. So this says that x is less than negative 3. This says that x is greater than negative 10. So the solution to the original would be the intersection of those individual solutions to the simple inequalities. And so that's what you do. All right. Now I want to say something else. And this is another approach. So listen carefully to this. Now you need to know this because this is going to be important in the second part of this lesson. So there'll be a second video that's going to cover another idea here. But here's the other approach. Now again, you need to know this one. Okay, that's important. All right, here's the other approach. So I'm going to go ahead and write this problem over again. This is number 1 again. Negative 64 is less than 6x minus 4 is less than negative 22. All right, so remember in the first approach, we split it up as two simple inequalities with the word and, so meaning the intersection, all right, to get us to find the solution to the original. Okay, so in the second approach, now listen carefully, do you see that when you look at those three parts here, the variable only appears in the middle. So since the variable only appears in the middle part, it is very easy to find the solution to the original, by getting the variable by itself in the middle. All right, so what that means is this. Just like we did before, I'm going to go ahead and cover this part up just to kind of explain something. If all we had was this, how would you get x by itself? Well, you would add 4 to both sides, right? Okay, so we would say this, plus 4, plus 4. But remember, this is a compound inequality. How many parts are there? 1, 2, 3. So if you add 4 to the middle part, you have to add 4 to the right-hand side, and you have to add 4 to the left-hand side. And that kind of brings us back to this here. Remember we did this? Add 4 here. You see it's right here, right? I'm sorry, right here. Add 4 to negative 64. You see it right here. We added 4 to negative 22. You see it right here, right? Okay. Now let's combine like terms. A negative 64 plus 4 is a negative 60. It's less than 6x. It's less than negative 18. And then now, think about what we have. So you get x by itself. You can divide both sides by 6. And so when I divide, I didn't mean both sides, I mean all parts. When I divide all parts by 6, I get negative 10. It's less than x, because 6 divided by 6 is 1. It's less than negative 3. And so notice as an inequality, is what we have. Negative 10 is less than x, is less than negative 3. And that's what you had here, right? Negative 2, all the solutions are between negative 10 and negative 3. Now I want to come back and say something. You may be asked to write the solution, to show the solution in terms of a graph, interval notation, and as an inequality. If you're told as an inequality, you must write it like this. So you have to come back and look at what we have here. So all of my solutions are between negative 10 and negative 3. So that's your answer as an inequality. No equal sign because it's just an open circle. And so notice it for this problem here, it was a lot quicker to do this way, right? Okay, see how easy it was? And so your graph, the solution set, you'd say negative 10, negative 3, open circle, and then shade. And then the inequality, you would say parentheses negative 10, comma, negative 3 parentheses. Okay? But it is important because in the next part, in the next video, you're going to see that one of the problems, you will not be able to do it this way. You are going to have to split it apart, and there's a reason. So we're going to look at that in the next video. All right, so two approaches. You can split it up as two simple inequalities with the word and. A little bit more work, but you need to understand this because that's important later on. Or you can solve it like this, where it's very easy to get the variable in the middle. All right? Okay, let's look at number 2. So we have this for number 2. So let's say this is number 2. We have, let me go ahead and get it. All right, we have 2 is less than 8 plus 3m is less than or equal to 5. So 2 is less than 8 plus 3m is less than or equal to 5. And I'm going to go ahead and do it both ways. So we're going to do the first approach. So the first approach is to rewrite this as two simple inequalities. So I'm going to say, I'm going to go ahead and write this one first. I'm going to cover up this part here. So we have 2 is less than 8 plus 3m, right? And at the same time, so I'm finding the solutions to this. So the solutions to this compound inequality would be any real number for m in which 2 is less than that value, and at the same time, that must be less than or equal to 5. So 8 plus 3m must be less than or equal to 5. Okay? So 2 is less than 8 plus 3m, and at the same time, 8 plus 3m must be less than or equal to 5. So the first approach is to rewrite the compound inequality as two simple inequalities. Now we're going to solve each of those simple inequalities next. So I'm going to subtract 8 from both sides. So 2 subtract 8 is a negative 6. It's less than 3m. Divide both sides by 3. Negative 6 divided by 3 is negative 2. It's less than m. So the solutions to this right here, solutions to this simple inequality would be any number, any real number that is greater than negative 2. That's what this means. So remember, you can rewrite this. Negative 2 is less than m as m is greater than negative 2. So any real number greater than negative 2 is a solution to this simple inequality. Don't say it's the solution to the original because you don't know that. You got to look at this as well. Okay? All right, now let's look at this one. So subtract 8 from both sides. I get 3m is less than or equal to 5 subtract 8 is a negative 3. Divide both sides by 3. The solutions to this simple inequality would be any real number that's less than or equal to negative 1. Okay? All right, now remember, any real number greater than negative 2 is the solution to this simple inequality. Any real number less than or equal to negative 1 is the solution to this one. Okay? So now we got to figure out, well, what's the solution to the original? What's the solution to this compound inequality? So that's where we're going to look at each of the graphs individually and then look at the intersection. So the word and, with the word and, you're going to think of the word intersection. Intersection. Okay, so let's do the first one. So, well, first of all, let's put the numbers on the number line, negative 2 and negative 1. So we know that negative 2 is smaller than negative 1. Make sure you put it in the correct order. So m is greater than negative 2. Notice there's no equal sign, right? So you're going to go to the right like this. Here, you're going to shade in any number that's less than negative 1, less than or equal to. So notice there is an equal sign, so closed circle, make it look closed. You got to make sure it looks closed this way. And so now the solution to the original would be, where do those two graphs overlap? So they overlap from negative 2 to negative 1. So the graph, you can say negative 2 to negative 1. All right, now notice, see there's an open circle here, right? And this is closed. So you're going to say open, closed. Make sure you're careful. Open, close. Open because this is open, close because this is closed. And shade in every number between them, every real number. So there's an infinite number of solutions. All right, so there's the graph of the solution set. The interval notation. That's easy. Parentheses, negative 2. Remember, always go from left to right. Always make sure you go from smallest to largest. -2 to -1 with a bracket. Make sure this looks like a parentheses, and make sure this looks like a bracket. And now the inequality notation, you're just going to look at what you see here. So you know that -2, so your solutions would be any number in which -2 is less than x, and then x, any number less than -1. Less than equal to -1, sorry. Less than or equal to, because it's a closed circle. So this is this. Okay? All right. Now let's do the same problem the other approach. So let's do number 2 again. Here's number 2 again using the other approach. So 2 is less than 8 plus 3m is less than or equal to 5. Okay, so the other approach is this. So if you look at your parts, the variable only appears in the middle part. Whenever that's the case, that's the easy kind to where you don't necessarily have to write it as two simple inequalities. You can easily solve this compound inequality by getting the variable in the middle. All right, one reason is because on the outer sides, on the left and the right, all you see are numbers. You don't see any variables. Okay, the variable only appears in the middle. Now we're going to subtract 8 from both sides, 8 from all parts, I should say, just like this. And notice this kind of looks very similar. See where you had -2 and a -8? That's what you have here, right? -2 and -8. And you see where you're adding, if you cover all these other parts here, you're adding, you have 8 and a -8. That is this right here. You see that? So you have 5 minus 8. That's this right here. Okay? So notice this right here is this. It's just that here you wrote it as two simple inequalities with the word and in the middle. Combining like terms, 2 subtract -8 is -6 is less than, these have to be 0, and you get 3m in the middle is less than or equal to, and then 5 subtract -8 is -3. Getting the variable m in the middle, we're going to divide all parts by 3. And so -6 divided by 3 is a -2 is less than m. 3 divided by 3 is 1 is less than or equal to -1. And there's your inequality. There's your solution. This right here is this. And so now as a graph, you're going to put that on the number line in order. No equal sign, so you're going to put an open circle on -2. There's an equal sign here, so that means -1 is a solution. So you can put a closed circle, and you're going to shade in everything between them. Okay? And then your interval notation, you're going to say parentheses -2, go from left to right, parentheses -2, comma, -1 with a bracket. All right? And so that's it. So there's your solutions written in different ways. So this is written as an inequality. This is written as a graph, and your solution here is written in interval notation. All right, so that's number 2. Let's do one more. So this is number 3. Okay, so number 3, let's suppose we have 2 is less than 8 minus 3m is less than or equal to 5. So the difference between number 3 and number 2, if you look at it, is that the coefficient of m are opposites. So this is -3, this is +3. Everything else is the same. So I wanted to do that just to show you what you would do if the coefficient is negative. So we're going to do it both ways. So the first approach is to rewrite this compound inequality as two simple inequalities. So 2 is less than, so you cover up this part if you have to. So 2 is less than 8 minus 3m. Okay? And at the same time, 8 minus 3m must be less than or equal to 5. Okay? Then we're going to solve each of those simple inequalities individually. So let's do this one first. So I'm going to subtract 8 from both sides. I'm trying to get -3m by itself. And 2 subtract 8 is a -6. It's less than and that's 0 here. 8 minus 8 is 0. Negative 3m. Now be careful. You got to get m by itself, but remember the coefficient here is negative. So I'm going to divide both sides by negative 3. But remember, when you divide or multiply an inequality by a negative number, you have to reverse this inequality symbol. Don't forget to do that. Negative 6 divided by negative 3 is 2. So 2 is greater than, you got to reverse, 2 is greater than, and then negative 3 divided by negative 3 is 1. 1 times m is m. All right? So the solutions to this simple inequality right here, the solutions to this simple inequality would be any real number that is, see you have 2 is greater than m, right? So any real number that's less than 2. So this right here means any real number less than 2. So 2 is the greatest. So any real number less than 2. All right, so that's the solution to this. Now let's do this one. So remember, be careful. Whenever you multiply, divide by an inequality by a negative number, you have to reverse. So don't forget to reverse. Over here, let's subtract 8 from both sides. That's 0. So I got negative 3m is less than or equal to 5 subtract 8 is a negative 3. Divide both sides by negative 3 to get m by itself. So notice I'm dividing by a negative number again. So I got to reverse this. Don't forget to reverse this. Negative 3 divided by negative 3 is 1. 1 times m is m. So m is, we've got to reverse less than or equal to, so it becomes greater than or equal to. Negative 3 divided by negative 3 is 1. Okay? And so now I found the solution to this simple inequality, which is this. So any number greater than or equal to 1 is a solution to this. So we got to find, though, the solution to the original. So what we have to do is, so the solution to the original means this. The solution to the original would be any number less than 2, and at the same time must be greater than or equal to 1. That's what that says. So let's look at each one individually. So here's 1, here's 2. Put them in order. 2, 1. Put them in order. So m is less than 2, open circle, going to the left. M is greater than or equal to 1, closed circle, going to the right. And so the solution to the original would be the intersection of those two graphs. And so the graph then, you're going to say 1, 2, so closed circle and open circle, okay? So closed circle on 1, open circle on 2. So you're going to shade in everything between them. So there's the graph. The interval notation, you're going to say bracket 1, closed circle bracket, make sure it looks like a bracket, 1 all the way to 2, parentheses. Make sure it looks like a parentheses. And so inequality notation, just look at this. So the inequality would be any, and I should have used, and I apologize for that, but see the variable here is m, so I should have used an m here. Sorry about that. That's an m. Make sure the variable is consistent. Okay. Okay. So just make sure the variable is consistent. All right. So the inequality notation would be where m is less than 2, and at the same time m must be greater than or equal to 1. Okay. So the inequality for this is this. So m is between 1 and 2. M is between 1 and 2. Okay, so including 1, so you see an equal sign, and not including 2, so you don't see an equal sign. All right. Now let's do number 3 using the other approach. So I'm going to rewrite number 3 using the other approach. So this is number 3 using the other approach. 2 is less than 8 minus 3m is less than or equal to 5. So in the other approach, we notice that the variable only appears in the middle part of this compound inequality. So it would be very easy to get the variable by itself. So I got to get rid of this 8. So to get rid of this, I'm going to have to subtract 8 from all parts, just like this. What you do to one part, you have to do the other. So make sure you, on the left side, you say subtract 8. In the middle part, you say subtract 8. And on the right part, you say subtract 8. You must show all these parts. Okay? 2 subtract 8 is a negative 6 is less than 8 subtract 8 0. 0 and a negative 3m is a negative 3m. It's less than or equal to, and then 5 subtract 8 is negative 3. So everything you write must be mathematically correct. So if you say subtract 8, you better say subtract 8 on the left. You better say subtract 8 on the right. Now we're going to get the variable m by itself. So to get the variable m by itself, we're now multiplying by negative 3. You got to be careful. You're multiplying by negative 3. The opposite, I'm going to go ahead and rewrite this over. The opposite of multiplying by negative 3, is to divide by negative 3. But what you do to the middle part, you have to do the right-hand side, and you have to do to the left-hand side. And you got to remember this. Since I have an inequality and I'm dividing by negative 3 or multiplying by a negative number, I have to remember to reverse those inequality symbols. So negative 6 divided by negative 3 is 2. Is greater than m is greater than or equal to negative 3 divided by negative 3 is 1. Okay? Now, look how this looks though. Normally in all the other problems, when you look at that inequality, the smaller number was on the left and the larger number was on the right. This is correct, all right? But it's just not written in the order that you naturally look at, That's natural to you. So you can rewrite this going backwards as well. So 2 is greater than m is greater than or equal to 1 means the same thing as 1 is less than or equal to m is less than 2. So these two mean the same thing. So you just wrote it backwards. When you put this in the number line, you need to make sure you put it in the correct order. So don't put 2 here and then 1 here, because 2 is not less than 1. So make sure you put it in numerical order. So put 1 first, then 2. And notice that on 1, there's an equal sign, so that's going to be a closed circle. On 2, there's no equal sign, so that's open. And you're going to shade in everything between them. So there's your graph. And then in interval notation, that's where you can use parentheses and brackets. So there's closed, you can use a bracket. So my solution would be any real number between 1, including 1 because of the bracket, and up to 2, but not including 2. Okay? And so notice that the way you solve this looks different than this, but there are some similarities as we discussed before. But whenever the variable only appears in the middle, it is easier, or I should say quicker as well, to do it this way. All right. But you have to know this way as well, because in the next lesson there is a problem where you are going to have to do it this way. You cannot do it this way. All right. Okay, so that is our first lesson on solving compound inequalities.